Hi everyone. So in this slide, we are going to cover the class 10th CBSE science subject. So under that subject, we are going to see the chemistry part. On the chemistry part, so we are going to cover the one of the important chapter for second term examination. That is fifth chapter. That is periodic classification of elements. So from this chapter, we'll get a 5-mark questions. 5 marks we'll get from this question chapter. Okay. Now, very important chapter. So they'll ask a more analytical type of question. They'll ask from here. Okay. So just we'll start the. So on this slide, we're going to cover the 3 important topics. That is Daubeney triad and Newlands Law of active and Mendeleevs periodic table. These are 3 topics that we are going to cover from this slide. Okay. First, we'll go to some introduction part about the periodic classification of elements. So already we are familiar with the matter. So matter around us present in the form of elements, in the form of compounds, in the form of mixture. Already we covered this. You may learn in the 9th standard. Okay. So elements. So this element will contains atoms of only one type. Okay. Element is one of the pure form of matter which contains only one type of atoms. Okay. At present, there are 180 elements are known to us. Okay. And they have a different properties, different physical and chemical properties. Out of these 118 elements, only 94 are naturally occurred elements. Remaining elements are synthetic elements. Okay. So in your mind, you'll get one question: why there is a need to classify the elements? See here. So we have 180 elements are there. They have different physical and chemical properties. So there is a need to classify the elements. The classification of elements help us to learn, to understand, and remember the names and properties of the different elements. The classification helps us to learn easily and to understand easily the elements and to remember the names of the compound, names of the elements, and the properties of the elements, different elements. It becomes very easy if we classify the elements. So that's why there is a need to classify the elements. Okay. For classifying the elements, the first attempt was done by the Daubeney triad. Daubeney is the first chemist who attempted classification of elements. So this classification was did in the 1870. Okay. So Daubeney was the German chemist, and he tried to arrange the elements with the similar properties in a group into the groups. Just he tried to arrange the elements with the similar which are having the similar properties. He made in group, and he identified some groups having the 3 elements, and he kept one name to that elements. That group as a triad. So what do you mean by triad? Triad, a group of elements, a group of 3 elements, a group of 3 elements. Okay. Next. So he shown that when the 3 elements in a triad were written in the increasing order of atomic masses, the atomic mass of the middle element was roughly equal to the average of the atomic mass of the other 2 elements. This was the one he found. Okay. He found that the atomic mass of when he made a 3 elements in a group, and he called that as a triad, and he found that while arranging elements in the increasing order of the atomic masses, he found that atomic mass of the middle element was roughly equal to the average of the other 2 elements. Okay. So by his classification, he made a 3 triads. In triad 1, lithium, sodium, potassium is the triad 1. So you see the atomic masses. He just arranged the elements in the increasing order of atomic masses. Okay. Atomic mass 7, 23, 31. This is atomic mass of the lithium, sodium, potassium. Okay. So what he found here? He found that atomic mass of the middle element, atomic mass of the sodium element is equal to the average of the other 2 elements. Just see the average of other 2 elements, 7 plus 39 by 2 equal 23. Is the average of the this average equal to the atomic mass of the middle element. Same way, there is one more triad there, his triad, that is the calcium, strontium, barium. Calcium, strontium, barium. Okay. So here also calcium atomic, just calcium, strontium, barium. Okay. This is atomic masses. Just arrange the elements in increasing order of atomic masses. Here also you can see this. Atomic mass of strontium is equal to the average of the other two elements. Just to see the average of other two elements, that is equal to 88.5. That is roughly this average is roughly equal to the atomic mass of the middle element. Next, third triad, chlorine, bromine, iodine. You see this bromine, chlorine, bromine, iodine. Here also, see the third triad number 3. Okay. So here also the atomic mass of the bromine is roughly equal to the average of the other two elements, that is around 81.25. This is approximately equal to the atomic mass of the bromine. So just he made 3 triads from the known elements. Okay. So I think you understood what he called as Dobenian triad. Just he tried to arrange the elements with the similar properties in a group, and he identified some groups having 3 elements in each, and he kept one name called as triad, and also show that the elements in the triad, while writing in the increasing order of their atomic masses, he found that or shown that atomic mass of the middle element was roughly an average of the atomic mass of the other two elements. Okay, his principle, Dobenian's principle. Okay, next, but there are some limitations are there with the Dobenian's triad. Okay, now, so if you see the limitations of the Dobenian's triad, from all the known elements could not arrange the, so all the known elements could not be arranged in the form of triads. Just he made 3 triads. One is the lithium, sodium, one triad. This is the triad number 1, triad number 2, triad number 3. Just he made only 3 triads. Okay, this is the first limitation. Okay. Next, second limitation. So this Dobenian triad not applicable to them for very low atomic masses, the elements with a very low atomic masses and very high atomic mass element. This Dobenian triad is not applicable. Okay. For example, we can't make these elements in the triad. Okay. There is fluorine, chlorine, bromine. You see the atomic masses. Okay. So atomic mass of the chlorine is very smaller compared to the other 2 elements. Atomic mass is very smaller. Okay. So we know this atomic mass is chlorine is atomic mass is 35.5, and bromine atomic mass is 80. You see the atomic mass of this fluorine, that is around atomic number 9, which is around 18. Around 18 atomic mass. Okay. See, if you see the average of these two, that is not equal to the, you see the average of the first and third element. It's not equal to the, not average, not equal to the, not roughly equal to the, it will come around the 45. Okay, it will come around the 45. This is a lot of difference there. That means, so this Dobenian triad not applicable to them for elements which have a low atomic mass and very high atomic mass. Very high atomic mass. These are 2 limitations that are with the Dobenian triad. Okay, just he made only 3 triads, and this Dobenian triad not applicable to the elements with the very low atomic mass or very high atomic mass elements. You can't arrange them in the form of triads. Okay, though there are limitations are there, but so this attempt of Dobenian encourage other chemists to correlate the properties of elements with the atomic mass. Okay. But though there are some limitations there with the Dobenian triad, but his work given an encouragement to the other chemists to correlate the properties of elements with the atomic mass. So among the one scientist, that one of the chemists is Newland. Okay, just he correlated the properties of elements with the atomic mass. Okay, next we'll see the Newlands Law of activeness. Newlands Law of active. Okay, here you can see the person John Newlands. Okay, so in the year 1866, the English scientist. So he tried to arrange the elements. He arranged the known elements in the order of increasing order of atomic masses. Just he arranged the elements in the increasing order of atomic masses. Okay, but keep in mind, so Newland was the first person to divide the periodic table of chemical elements in the order of atomic mass. Okay, so here the first person just he divide the first just to arrange the elements in the increasing order of atomic mass to give the table. Okay, next, just he started with the elements having the low atomic mass, that is element that is the first you started with the hydrogen, just to lighter that is the lowest atomic mass element, and ended with the thorium, either 56th element. So just here in the only 56 elements from the hydrogen to the thorium, hydrogen to thorium, just started element. So he tried to arrange the elements in the increasing order of atomic masses. Started with the hydrogen and he ended with the thorium. That is the last element at the time, known element at the time. That is 56th element. While arranging the elements, he found that every eighth element had a property similar to the first element. We started with the we started with the hydrogen. Okay, so just he started with hydrogen and arranging like this and arrange to the like this he arrange the elements. Okay, up to the thorium arrangement. Okay, so while arranging the elements, he found that every eighth element. Okay, you start from hydrogen 1, 2, 3, 4, 5, 6, 7. Okay, fluorine is the fluorine is the eighth element. Okay, he found that eighth element had a property similar to the first element. And he compared this to the octave found in the music. That's why. So he called this law as a law of active, and also we can call it as a Newlands Law of active. Newlands Law of active or Newlands Law of active. Okay. You see, suppose we consider first element is the lithium, and if you see the eighth element, will show the similar properties. So eighth element is the sodium. Same way, if you see the beryllium is the first element, you start from the first element. So its eighth element is the magnesium. Okay. We found that every eighth element resembling the properties like a first element. Okay. So like this, he made a classification. His classification. Okay. Just so he made a so 8 groups. He made just 7 groups. He made. Okay. 7 groups. He can made a 7 groups. Okay. Around. So he arranged the elements in a 7 groups. 7 groups. Now, when you see the limitations, is about the so Newlands just he arranged the elements in the increasing order of atomic masses. Okay, and he found that every eighth element resembling the properties like a first element, and he compared that to the musical notes octave found in the musical notes. That's why he called it a law of active or Newlands law of active. This classification is called as a law of active. Okay, but there are some limitations are there with this Newlands law of active. That is, it was found that law of active was applicable only up to the calcium. Up to the calcium element. Here you can see the calcium element. What is the law of active? Every eighth element resembles the properties like a first element. So that was applicable only up to the calcium. After the calcium, every element did not possess the properties like a first element. This is one limitation. Up to calcium only, the law of active is applicable. Okay, next. So next second limitation. He was found that so it was assumed by the Newland that only 56 elements exist in the nature. No more element could be discovered in future. So that is he thought. But later on, several new elements were discovered and whose properties do not fit in the law of activeness. So he thought that there's only 56 elements in the nature. Okay, but after later on, so many new elements are discovered. That elements properties are not fit in the Newlands law of active. So the one of the main drawback or limitation of the Newlands law of active. Next, so in order to fit the elements in his table, Newlands adjusted 2 elements in the same slat. You see here, he adjusted the 2 elements in the same slat. Cobalt and nickel and cerium and lanthanum. He tried to adjust 2 elements in the same slat. Okay, and that too he put in the unlike elements under the same note. Okay, so actually you will see that hydrogen, fluorine, they will show the different properties as compared to the cobalt and nickel. Okay, same way you will see the cerium and lanthanum will show the different properties when compared to the group elements. Okay. Though he adjusted, but not kept in the same similar group. He kept in the dissimilar, unlike element with the unlike elements. These are the main drawbacks of the Newlands law of active. First one is that, what is the first drawback? It was found that law of active was applicable to only up to calcium. First one. Next. So it was assumed by the Newland that only 56 elements exist in the nature. No more element could be discovered in future. But there are several elements are discovered that elements are not unable to fit in the, they are not fit in the Newland's law of active. Okay. Next. So next one, what is the main limitation? So in order to fit the elements in his table, Newland adjusted 2 elements in the same slat. He adjusted 2 elements in the same slat. But that too he put in the other unlike elements, with other unlike elements, just under the unlike elements he put. So these are the main drawbacks or limitations of the Newland's law of active. To overcome from this limitation, so we have one more new table, that is Mendeleevs periodic table. Mendeleevs periodic table. Okay. Now, so Mendeleev periodic table. So he started his table of work with the 63 elements. With the 63 elements. Okay. And just his work started with the 63 elements. He examined the relation between the atomic masses. He examined the relation between the atomic mass of the elements and their physical and chemical properties. Just while classifying the elements, just he examined the properties of elements with their physical and chemical properties. Among the chemical properties, Mendeleevs mainly concentrated on the compounds formed by the elements reacted with the oxygen and hydrogen. Okay. Among the chemical properties, Mendeleev concentrated on the compounds formed by elements with the oxygen and hydrogen. Okay. Why he selected oxygen and hydrogen? He selected hydrogen and oxygen as they are very reactive and form compounds with most of the elements. So actually these two elements are very reactive elements, and they form mostly every element they form a compounds with these two elements. Most of the elements will form a compounds with these two elements. Because of that, he chosen the hydrogen and oxygen compounds. Okay, next. And the formula of hydrates and oxides formed by the elements were treated as the one of the basic property of elements for his classification. Okay, he took the formulas of hydroxides, and the same way he took the formulas of oxides formed by an element and were treated as one of the basic property of an element for its classification. For his classification, he took the formulas of oxides and hydrogen formed by the elements. With the help of that, he just classified the elements. Okay. Now, so he took the 63 chords. On each chord, he wrote on the property of every element. He wrote on the property of one element, and he shorted out the elements with the similar properties and pin the chords together on the walls. And he observed that most of the elements got a place in his periodic table, were arranged in order to their increasing order of atomic masses. Just arrange the elements in the increasing order of their atomic masses. It was also observed that the occurrence of periodic recurrence of elements with similar and chemical properties. While arranging elements, he observed that the physical and chemical properties are repeating after a certain interval of time. Okay. So based upon that, he given one law called as Newlands Mendeleevs periodic law. He given one law, Mendeleevs periodic law. Okay. So according to this law, state that the properties of elements are periodic functions of their atomic masses. Periodic function of their atomic masses. Okay. These are important. They'll ask one more question. So define the Mendeleevs periodic law. The properties of elements are the periodic functions of their atomic masses. Atomic masses. Okay. In the Mendeleev periodic table, so contains vertical columns. You can see the vertical columns here. This is the vertical columns you can see. Okay. These vertical columns, he called as groups. These are the vertical columns. These are the these are the groups, and horizontal rows he called as the periods. You can see the periods here. Okay, period number 1, period number 2, 3, and these are the periods. Okay, the periods in the Mendeleevs periodic table. Okay. See, he classified the elements. He arranged the elements on the increasing order of atomic number. Along that, he arranged the elements based upon the reactivity of the elements toward the hydrogen, oxygen. Based upon the reactivity toward the oxygen and hydrogen. Okay. So based upon that, just arrange the element. You see here, the hydrogen. This hydrogen will form a oxides of R2O type oxides. It will form a hydrates of RH type hydrates. So the elements within the same group, they will form the same type of hydroxides and oxides and hydrates. Okay. Same way, if you see the second group element, this second group element will form a similar types of oxides and hydrates. Okay. Beryllium, magnesium, calcium, strontium, they will show the similar type, they will form a similar type of oxides and hydrates. Same way, if you see the third group element, they will show the similar type of oxides and hydrates. So basically, like that, he made a elements that show the similar chemical property toward the hydrogen and oxygen. He made it in the one group. Just he kept it in one group. Okay. Just he arranged the elements in the increasing order of atomic masses. At the same time, he kept the elements under the same group, which will show the similar properties, similar chemical property toward the hydrogen and oxygen. So like that, just he made the elements, arrange the elements in the vertical columns and horizontal rows. Okay. So you can see. So if you compare this oxygen and sulfur, both will show the similar type of oxides and hydrates. Not only that, if you see the chromium and cerium also, they will show the similar type of oxides and hydrates. So the elements which show the similar properties, chemical properties with the hydrogen and oxygen, that element he kept in the one group. Now, next we will see some of the achievements of the Mendeleevs periodic table. Okay. Now, when you look at the Mendeleevs periodic table, so you see that some elements are here. Okay. The elements with slightly greater atomic mass were placed before the element with slightly lower atomic mass. Okay. So with a inverted sequences, so he inverted some cases he inverted sequences so as to group the elements with similar properties. So his main motive is to group the elements with similar properties, to group the elements which are having the similar properties. Okay. So that's why you see here cobalt, and you see the cobalt and nickel. Actually, cobalt have a more atomic mass than the nickel, but to group the elements with the similar atomic masses, similar chemical properties, just he made like this. Because of that, just he made some inverted sequences. Okay, you can see some same way. You can see some other case also. Okay. In other case also, you can see some of the element. You see here. In the case of aluminum and silicon, this is aluminum and silicon. Aluminum have a 29.98, silicon have a 28. See, here are some inversion is there. So why he kept like this? To group the elements with the similar properties. This is the motive. Okay. Now, so this is the one main achievement. Second, so he left some gaps in the periodic table. Okay. You can see some gaps here. You can see some gaps also here. You can see some gaps here. Okay. Just he left some gaps in the periodic table. So with the prediction of the existence of some elements that were not discovered at the time. Okay. So he gave some gaps in this periodic table. So why he given gap? Just prediction of the existence of some elements which were not discovered at the time. Okay. Next one. He named the future elements. He named some future elements by prefixing the Sanskrit numerical yaka to the name of the preceding element in the same group. Okay. So later on, that element became a scandium, gallium, and germanium. later on discovered. First, they are similar to like a Eka boron, Eka aluminum, and Eka silicon. This is one of the main achievement. And one more thing, main achievement is that, so given a space for noble gases like a helium, neon, argon was discovered. So later on, as they were present in a, actually they are present very, very low concentration in the atmosphere. So because of that, so it made some late for discovering these elements. But for these elements also, he given a space. He left some space to these elements in his periodic table. Okay, he left some space to these elements in his periodic table. Okay, these are the main achievements of the Mendeleev's periodic table. But there are some limitations are there with the Mendeleev's periodic table. Main limitations are no fixed position given to the hydrogen. Okay, why? Because you will see the electronic configuration of the hydrogen that will resemble like a alkali metal. Okay. And also, like alkali metal, it will combine with so this hydrogen will combine with the halogens and oxygen and sulfur and form a similar type of formulas. Okay. For example, hydronidine. Same way you take the sodium also. When hydrogen react with halogen, it form a this type of same type of compound will form a sodium also. When hydrogen react combined with oxygen, forming H2O type of sodium will also form a Na2O type. When hydrogen combined with sulfur, form a H2S type. Same way, sodium also will make a part Na2S type. Okay, so their electronic configuration is similar to resembles like a alkali metals, and also they will form a similar type of compounds with the halogens. It also form a similar type of compounds with the halogens, oxygen, and sulfur. And it will have the same type of chemical formulas. So same way, along that, it also will show like it also just like a halogens. Hydrogen also exists like a diatomic molecule. So halogens like a fluorine in the form of F2. Fluorine will be exist in the form of F2. Fluorine will be exist in the form of Cl2. So they are dimeric form. So this will be exist in the diatomic molecule form. Halogens will be exist in the diatomic molecule form. Same way, hydrogen also will exist in the diatomic molecule form. It combines with both metals and non-metals also to form a covalent bond. As like a halogens, hydrogen also will combine with the metals and non-metals to form a covalent bond. So it is showing the properties like a alkali metals at the same time like a halogens. So, but the chemist Newland unable to fix the correct position to the hydrogen in his periodic table. That is one of the drawbacks. Next one. Actually, this periodic table is based upon the increasing order of atomic masses. Elements arranged in we arrange the elements in the increasing order of atomic masses. But there are some elements of the isotopes of the isotopes are discovered after long after the Newlands periodic classification. Okay, these isotopes are unable to fit in the Mendeleev's periodic table. So isotopes are discovered after long after the Newlands periodic classification of elements. But that made a challenge to the Mendeleev's periodic table. That elements are not that isotopes are unable to fit in the Mendeleev's periodic table. And one more thing, the atomic mass of element did not increase in a steady manner while going from one element to other element. You see the atomic masses of the elements. You see the atomic masses of the element. From lithium, 6.939, beryllium, 9. There is no steady increase in the atomic masses. Okay, so that made us to which made it very difficult to predict the number of elements that could be discovered between the two elements. So the mass is not increasing in regular manner. Okay, so that made it very difficult to predict the number of elements that could be discovered between the two elements. We don't know how many elements will be exist between the two elements. So these are some of the drawbacks or limitations of the Mendeleev's classification. Okay, thank you. Have a nice day.